Hello everyone, and in this video I'll be taking another example of time series, and this time I'll be smoothing the data and I'll be finding out center of moving average and you know I'll just try to smooth the data before moving into the prediction. So this is the data which I've got. I've got the data of quarter, each quarter. Inserted a variable called time here, you know, and I've got sales. Now, if I plot this entire data of sales, that's what I get here. If you go to insert, I'm going to do a plot here. So you can see there are a lot of ups and downs in the data set. And let me just add data to my x-axis also, as I desire for all the years and quarters. I'll click OK. OK. So that's the quarterly data, and you can see there's a lot going on in this particular data set when it comes to time series. And I'll be using the very multiplicative model as I discussed in the previous class, which is right here. And the same model I'll be using to predict. But this time I'll change the things a bit. You can see the previous lecture how exactly I've used this model without smoothing the data. What I'll do is first I'll be calculating moving average. So this is a technique for smoothing the data and avoiding all these bumps in the data set. Then I'll be calculating center of moving average. I'll be telling you the logic of it. Then I'll take the seasonality and irregularity out. Same way, I'll remove the irregularity and take the seasonality out of the data set. Then I'll be also introducing you a concept of deseasonalize. So it is pretty simple. I'll be dividing YT by ST, and that will be deseasonalizing the data. This is actually understanding how the irregularity and trend come in combination can behave. So you can use it, you can leave it, and then I'll be using trend value pretty simply. And I'll be using regression for it, and then I'm to make prediction by using simple trend multiplied by seasonal trend. So for more detailed thing, you can see the previous video. So the first thing I'm going to do is I'm going to use the moving average technique. So either you can simply, I'm going to use a 4-year moving average, and you can use the moving average of 5-year also. But since the data is arranged as per 4 seasons, so I'll be using a 4 time period moving average. You can think it that way. So you can simply go to Go Data Analysis, select the moving average from here, click OK, and already given the data. It is sales right here from the top, label in first row, intervals is like I'm using a 4-year moving average, and I'm going to paste it right from here, click OK, and click OK. Of course, it is not going to calculate first two values right here, first three in fact, because this will be average of first four. You can see that. And next would be average of next four values right here. So you can double click and check how this entire function is moving, right? Third value, fourth value, and so on. And if you can see the last value, it is moving average of last four. So seems good, and get rid of them. So I have calculated a moving average. You can also use a manual formula to do that. And I'll tell you the concept why exactly I'm going to use the center of moving average. So just bear with me for a little time, right? So let's see how exactly the things are working out here. So if I talk about center of moving average, the concept is something like this. Just see it carefully. If I see 66.09, it is average of these four values right here, and it is sitting right here at the center, 66.09. That means there is no value in the data set against which it is associated with. Same if I talk about 65.73, it is actually an average of these four values, and it is exactly here, 65.73. So if you see, there is no association of these values in the data set. They are somewhere in between. But I need to operate mathematically, so I need something which can be related or mapped as as per location with respect to some values. If I calculate average of these two values, so it will be coming right back into this cell, which is against 64.12, and I can operate it. So if you're doing a moving average of even numbers, that's how exactly the things should work out. And that is going to help you out a lot in order to, you know, understand that how center of moving average actually works. So let me get rid of this entire drawing and let us understand. And I'll plot the center of moving average onto your, okay, just a minute. Okay, I need to just get rid of this. Fine, just a minute. So I'll also plot this center of moving average line onto the chart so you can easily understand that how the data gets smoothened up and how it is going to help us out in making better predictions. So let's do that. I'm going to calculate the center of moving average and I'll calculate it right from this cell. It will be average of 1 and 2. Scroll down. Last one will not make sense at all. So even if you do that, it will be like the value is only taking 60.26 and one value down. So it doesn't make much sense. So I'm going to get rid of it. Let me plot this CMA here and I'll see that how exactly it actually smoothens the entire data set. So I'm going to go to chart design, select data, add a particular variable here. I'll name it center of moving average. And notice carefully I'm going to select the blanks also. Why I'm selecting the blanks? If I do not select the blanks, the Excel will start plotting the data right from first data point, which I do not want. Because anyways, I mapped it from quarter 4. In fact, if you see here, in fact, against the quarter 3, if you see, I mapped it from the quarter 3. So in fact, what I should do is I will shift this entire data a little bit out. Sounds good. So that's how you can see there is a pretty much smoothing line here, but started from quarter 3. Now I'm going to do seasonality and irregularity out, and I'll explain you in a bit why. So it is YT divided by Y here, divided by my center of moving average, 0.972, and so on. I pull it down, and what I'm going to do is I am going to reduce the decimal places to 2. Okay, so if you see the center of moving average here, uh, then you can see that seasonality, the impact of seasonality and irregularity together on all the data sets here. So it is exactly seasonality is causing a 3% variation in the data set here, 3% here, 2% here, 2% here. You can refer to my previous video and you can understand that what do I mean by this 3% and 2% with respect to time series. Now, what I'm going to do next is I will take the seasonality, I'll isolate the seasonality trend out. And for that, I will be first of all taking the average of the seasonal components. And for that, let me zoom it out. I'll be doing it absolutely same way. So let me do it for quarters. So it is quarter 1. And then I will take average. So there are 4 quarters. And I'll use my average f function. So zoom it so you can see that better way is equal to average f function range. So I'll take this range right from here to here. Not this, actually the quarters. So I will start from quarter 4, quarter 3 in fact, because I'm going to calculate it from 197 and then I'm going to take it till here. And the criteria is right here. And I want to take the average of seasonality here. That's what I'm going to do. So I'm freeze it, function f4, and I'm freeze it here also, function f4. Sorry, I left this one, function f4. Enter, right? Yeah, seems good. Take an average of, you can see the third quarters and the fourth quarters. Here again, I'll use my VLOOKUP function, same way I did in the previous time series example. So I'll look up for the value of third quarter here. And in fact, what I'm going to do is I'm going to fill up the seasonality right from the top. So VLOOKUP function, lookup value is first quarter right here. And in this table array, I want it to search for, so I'll freeze it function f4, second column and false match. Okay, I'm to send it down. All right. In fact, I wanted to keep it. So far, I wanted to keep it till here. I'll be doing it later when I'll be making a prediction. So that's it. The seasonality has been isolated. Here, you can see that. The seasonality has been isolated. Now I'm going to calculate the trend value right here. And you know how to calculate the trend value. Deseasonalization is, of course, y divided by st. This is deseasonalization. That means you have taken the season impact out of yt, and if you take the season impact out, this is what you are left with. So there's no impact of season now here in this. Now let us calculate the trend value, and for that I know I have to run regression. I have to go to data analysis. I'll go to regression, click OK. My y variable is right here, sales, and my x variable is time, and let me paste it somewhere here at the bottom. It's okay. Okay, I've got my coefficients. My coefficients are in actually B44 and B45. So let me pick it up. So it is B44 is my first coefficient, which is beta 0. And I'm going to go function F4 plus B45 is my second. If you see, my second beta 1 value was there in B45. And I'm going to freeze it, function F4 times the time value right here. So that would be my trend value. And I'm going to put it down. As simple as that. So I've got my trend values, and now my prediction would be trend times seasonality right here, and that's how my prediction goes. So you can check that. That's my prediction using moving average. Now predicted values. Now what I want to do is I actually want to make prediction for next 4 quarters. So I would extend this time period first of all, and I'm to extend my trend values on the basis of that. Seasonality component, of course. Why it is not getting extended? Because I have not stretched my rest of the values. So rather what you can do is you can simply pick the values up because it's not there, moving average is not there. So let me pick it up, right? All the averages are filled up right from here, from this particular table for different seasons. And let me pull the trend values out. So these are my predicted values for the next quarter. These are my predicted values for next 4 quarters of the sales. Thank you very much.